Our today's topic is permutation and combination. What is permutation and combination? Very simply speaking, permutation and combination is the mathematics of arranging objects. What do I mean by this? Let's say there are 10 people, out of which 6 are men and 4 are women. Now we have to take a group photograph. We have 5 chairs in which out of these 10 people, 5 will occupy this chair and 5 will be standing behind these chairs. This is our problem as we speak in mathematics. So, in how many ways we can have this arrangement? We have 10 people, 6 men. So, might be all these chairs are occupied by men, or maybe 4 women occupy these chairs, 4 chairs, and the fifth is occupied by a man, and 5 are standing behind. So there can be numerous possibilities, many possibilities for this photograph to be taken, or to say in what we are concerned of, there can be a number of possibilities of arranging these chairs and people standing behind the chairs. How to do that? The study of arrangement is permutation and combinations. Later on, we'll understand how many ways are there to arrange objects. We'll study permutation, we'll study combination, and we'll know about these things. Let's start with first concept that is called fundamental principle of counting. And this is one of the most important logic that you will develop, which you will be using in your advanced classes or in advanced topics. The first thing we are saying is fundamental principle of counting. Let's say we have six digits: 1, 2, 3, 4, 5, and 6, and we have a slot. We have to fill the slot with any one of these digits. How many possibilities are there? We have 6 digits, so either this can be 1, or it can be 2, or it can be 3, 4, 5, 6. So there are 6 different ways of filling the slot. Okay, let's say we had 2 slots. So the first slot, we had 6 digits to fill. We had 6 different ways of filling the slot. After this, we had to fill this slot, the second slot. And if repetition was not allowed, meaning thereby that if we have used a digit here, we cannot use it here, then we are left with 5 digits now. So in how many ways this slot can be filled? 5 ways. Okay. So how many total number of occurrences are possible? Let's see. Let's say when this was 1, then second slot was 2 or 3 or 4 or 5 or 6. When this was 2, second slot was 1, 3, 4, 5 or 6. This way, this could be filled in 6 different ways, and the second slot could be filled in 5 different ways. So the total number of possibilities, that is in the terminology of permutation and combination, it's called occurrence. So the total number of occurrences is, see, 5 plus 5 plus 5. So this will be 6 cross 5. So the total number of ways of filling these slots is 6 cross 5. Okay, this is clear to you. So now we'll derive a formula for this so that we are able to solve such problems. Let's say this is an event. Let's say this event can be done in m different ways. Then we have the second event. This can be done in n different ways. Then we have third event, which can be done in p different ways, and so on. So the total number of occurrences for the event to occur will be equal to M cross N cross P. And if we have Q, R and so on, that will be M, N, P, Q, R and so on. This is called the fundamental principle of counting, or it is also called multiplication principle. Multiplication principle. Clear? So if an event can occur in m different ways, following which another event can occur in n different ways, following which the third event can occur in p different ways, following which fourth event can occur in q different ways, and so on, the total number of occurrences of the event will be equal to m cross n cross p cross q cross r and so on. So this is the fundamental principle of counting, or the multiplication principle. We have another principle which is called addition principle. Let's understand that principle also. Addition principle. What is addition principle? Let's say we had the slot that we had discussed in the start. We have one single slot, and we have 1, 2, 3, 4, 5, 6 from which we can fill this slot. So there were 6 different ways of filling this slot. Let's say we have another basket. This is one basket from which we are taking this, and we have another basket which has, let's say different objects. Let's say ABC. So we can fill this also. So there will be 3 different ways of filling this slot from A or B or C. And if we say that this can be either filled from this or this, then how many different ways do we have available for filling this slot? Understand this properly. We can either fill from this or we can fill from this. So total number of ways of filling this is, we have 6 different ways of filling this from this basket and 3 different ways of filling this basket. So total number of the ways of filling this basket will be 6 plus 3. That is, it can have 1 or 2 or 3 or 4 or 5 or 6 or A or B or C. So there will be 9 different ways of filling this slot. So deriving a generalized solution, we'll have, if an event can occur in m different ways, or it can occur in n different ways. There are 2 possibilities. Then the total number of ways of occurrence of this event will be m cross m plus n. So this is called addition principle. A very good example is given in NCERT book, that let's say we enter a room and there are 2 doors on this side and 3 doors on this side. Door 5, door 4, door 3, door 1, door 2. So a person is standing here. How many ways he has to get out of the room? 2 plus 3. That is, if this side was m, then m plus n ways. This is addition principle. And what was multiplication principle in this nomenclature? How to understand? Let's say multiplication principle. We have first room where we have 3 doors, D1, D2, D3. Then we had second room where we have, here we had m number of doors, here we have n number of doors. So a person coming from here, he can come out of this or this or this. Then he can enter through this or this. So there will be m cross n ways. So the difference between multiplication principle and addition principle is, we saw just for addition principle. In multiplication principle, one event occurs after the first event. The second event occurs after the first event. While in addition principle, the same event can occur in different ways, m ways or n ways or p ways. So in addition principle, we add all those ways. In multiplication principle, we multiply all those. We will see examples to understand the two properly. Example 1. We have the word rules. And we have to find out, using these letters, how many words can be formed. So there will be 4 letters. Let's say these are the slots in which these letters have to be filled. The first letter, the first slot can be filled in 4 different ways, either R, O, or S, or E. Now once we have used one letter, here. So now we'll have three letters left. So this can be filled in three different ways. Then we have two letters remaining. So this can be filled in two different ways. And finally, we'll have one letter only. So the total number of words that can be made from these four letters, and we are not talking of meaning, whether they have any meaning or not. We are only concerned with the possibility of formation of that four-letter word. So that will be equal to 4 cross 3 cross 2 cross 1. This is equal to 12, 12, 24. So there are 24 ways, or there are 24 different words that can be formed from these four letters. So let's see other examples from NCERT. The second example is given four flags. It says given four flags of different colors, how many different signals can be generated if a signal requires the use of two flags? Let's say there are the signal is this, and we have four different flags. So we can put it there here. We have four ways of putting the flag on the first signal. Then we'll be remaining with only three ways. We'll be remaining with only three flags for this second slot, the second signal. So the total number of ways will be 4 cross 3. That is 12. Okay. The third example is it says how many two-digit even numbers can be formed from the digits 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5. It says how many two-digit even numbers. For a two-digit number to be even, we'll have to put either 2 or 4 in this slot, either 2 or 4. So there are only two ways of filling this, but we have five ways of filling this slot. First slot is free, you can put any digit there. So the total number of ways will be 5 cross 2, that is equal to 10. Then we have example 4. It says find the number of different signals that can be generated by arranging at least two flags in order, one below the other, on a vertical star, if five different flags are available. So we have five different flags. Let's say this is the first, this is the second, and this is not a flag, but I'm just for the sake of understanding, I'm saying these are five flags which we have. It says by arranging at least two flags in order, one below the other, at least two. That is, this is the first possibility. We'll have two flags, or we can have three flags, or we can have four flags, or we can have five because it says at least. That means we are free to have more flags also. So these are the four different possibilities. We have to use these flags. So here we'll have this can be filled in five ways, this can be filled in four. So this is 5 cross 4, that is 20. Then we have 5, 4, 3, that is 5 cross 4 cross 3, 60. Here we'll have 5, 4, 3, 2. So 5, 4, the 20, 60, 120. Here we'll have 5, 4, 3, 2, 1. Again 120. So the total number of ways now additional principle will apply. So the total number of ways will be, if this will be used, 20 ways. If this will be used, plus 60. If four flags will be used, then 120. And if five, then again 120. So this will be 240, 300, 320. So the total number of ways will be 320. Clear? Our topic is permutation. What is permutation? Permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Let's say we have n number of objects. We can take all the objects at once, or we can take a smaller number of objects at one time. Let's say we have five and we can take two objects at a time. For example, we had in our when we were dealing fundamentals principles of counting, we were seeing that we had 1, 2, 3, 4, 5, 6, and we had to fill one single slot. So when we have n number of elements or objects, and r number of objects are taken at a time in a definite order. It's called permutation, and we write it like this, NPR. So the meaning of this is permutation of n number of objects taken R at a time. Now we are emphasizing on one word, in a definite order. What is the meaning of definite order? Let's understand this. Let's say we have n number of balls, all are of same color, black or white, whatever it may be. And we have to take three balls at a time. N number of balls, and we have to take R at a time. The order is not very important here, because whichever ball you will pick, that will be of the same color only. If these are all black balls, we have hundreds of black balls, and we just pick three balls out of that basket, we'll have three black balls. There won't be any order that this is the first ball or the second ball or the third ball, or balls are equal. So that is not a definite order. But if digits are written on the balls, like in billiards, 1, 2, 3, 4. If digits are written, then we have order. We can have, let's say, 1, 2, 3, or we can have 3, 2, 1, or we can have so many numbers. If we have 100 balls, these numbers can go up to 100. So when taken in a definite order, it's called permutation. Permutation. And when order is not important, order is immaterial, that is called combination. We will study combination after permutation. For the time being, just focus on this NPR, that is permutation of n number of objects taken R at a time. What will be the formula of finding permutation? Let's say we have seen this in our earlier examples. Let's say we have R vacant places to fill from, let's say this is 1, 2, 3, and this is the rth one. So we have r different vacant places to fill from n different objects. We have n different objects. Here we can fill in n different ways. Here n minus 1, here n minus 2, and here n minus r. No, here n minus r minus 1. See, when we are at place 1, it is n. When 2, it is n minus 1. So this is the place minus 1. At 2, this is, at 3, this is minus 2. So this will be n minus r minus 1. So total number of ways is equal to this. And what is this? This is our NPR. That is permutation of n number of objects taken r at a time is given by n cross n minus 1 cross n minus 2 up to n minus r minus 1. So this is the formula for NPR. So we saw we have a formula for NPR. A better formula can be derived if we have knowledge of factorial notation. Factorial notation. What is factorial notation? It is like this, or we can write it like this. So factorial notation, factorial n is the product of first n natural numbers, that is n into n minus 1 into n minus 2, 3, 2, 1. This is factorial notation. So if we have n minus r, it will be n minus r into n minus r minus 1 into n minus r minus 2, 2, 3, 2, 1. This is factorial notation. We will see some examples also on factorial notation. But for the time being, we are interested in deriving a formula for NPR. Let's say we have n number of objects, n number of objects taken R at a time, R at a time, where R is greater than 0 and less than equal to n. Okay. Then we saw that NPR was n into n minus 1, so on to n minus r plus 1. This was our NPR from our last derivation. Let's say we multiply the numerator and denominator by n minus r, n minus r minus 1, n minus r minus 2, so on 3 to 1. So let's multiply the numerator also, n minus r, n minus r minus 1, and so 3 to 1. This is just, we just saw n factorial of n minus r, and this is factorial of n. So this is factorial n by factorial n minus r. So this is our formula. So let's write it properly. NPR becomes factorial of n by factorial of n minus r, where r is greater than 0 and less than equal to n. This is our formula for NPR. Okay, we'll see certain more things. This is when repetition was not allowed. That is, we have this in definite order. What if there are repetitions? Let's see some more. Let's get deep into the subject. What if we have to take r at a time from n number of objects, and this is the rth one, and repetition is allowed. Repetition is allowed. Then we have n number of ways here, then n number of ways, and then n number of ways. So n into n into n r times. So then our NPR will be equal to n to the power r when repetition is allowed. Repetition is allowed. Okay. Let's see one, two, three more important things. What will be NPN? That is all taken at the same time. For example, we had seen the letter, four-letter word ROAC, rose, and we had seen how many ways are there, or how many different words can be formed from those four words. There were four letters taken four at a time at that place. Let's see what is NPN. That is the same thing. If four letters taken four at a time, this will be equal to factorial n by factorial n minus r. That is n minus n. That is factorial n by factorial 0. Factorial of 0 is equal to 1. You should remember this. So this is equal to factorial n. Let's see our example. We had seen rows and we had four slots. So four taken four at a time. We had solved it by this method, principle of multiplication by principle of fundamental principle of counting, 4 cross 3 cross 2 cross 1. Let's say what is this? This is factorial 4. Again, this is 4 cross 3 cross 2 cross 1. That is 20. 24 3 yeah, 12, 24. Okay. So now we have solved it not by logic but by formula. So this is NPN. What will be NP0 when not taken any? We say R, taken R at a time. What if taken 0 at a time? That is, we don't do anything. So there can only be one way of not doing anything. We have hundred or thousands of objects and not doing anything with it. There is only one way. This is the only way. Let's see by formula. It will factorial n by factorial n minus 0. That is factorial n by factorial n. This is equal to 1. So there's only one way of not doing anything. That is only one way of not studying. Just don't study. But if you want to study, there are several possibilities. You can study in the morning, you can study in the night, and so on. But a very interesting fact we were able to derive just now. We said NP0 is equal to 1. This is, by this we mean that even at R equal to 0, our NPR is defined. NPR is defined. Therefore, in the formula NPR given by factorial n by factorial n minus r, earlier we had said r greater than 0, less than equal to n. Now we can say this is r equal to 0 or r greater than 0. So this is our final formula for permutation. Now one final thing we will see. What if we have n number of objects, out of which p number of objects are of one type and others are of different type. What is the meaning of this? Let's say we have different balls, n number of balls, n number of balls, out of which we have p number of black balls, and the rest, that is n minus p, are different. They may be of different color, different numbering and all. Then how to find the permutation? In that case, the permutation will be factorial n by factorial p. Let's extend this. If we have p1 number of black balls, p2 number of, let's say, red balls, and so on, then the permutation will be factorial p1 into factorial p2 and so on. So this is the formula when out of those n number of objects, we have certain objects of the same kind and the rest are different. Let's see one example, example 1, to understand this. We have one example. It says the letter is Allahabad, and it says how many words can be formed using the letters from this word. Here we have L two times, and A is 1, 2, 3, three times. No, 1, 2, 3, yeah. So four times. A is four times. So the number of words that can be formed will be, this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So factorial 9 by factorial 2 into factorial 4. Others are different. So this will be factorial 2 cross factorial 4. What it will be? This is, we can do this like this: 9 cross 8 cross 7 cross 6 cross 5, and then we'll have 4, 4, 4, 3, 2, 1. Here we'll have 1 into 2, and this is factorial 4. So 4, 4 cancel. We have 2 here. So what is the, we'll multiply this and divide by 2. This comes to 7560. So this is about permutation. So we have seen permutation, NPR, which was equal to factorial n by factorial n minus r. The value of r is between 0 and n, both upper and lower limits included. So permutation is an arrangement of taking n number of objects r at a time in a definite order. So this was factorial n by factorial n minus r. In the start only I had told you there's another arrangement called combination, where the order is not important. For example, we had taken ROSE and tried to fill it here. Here order was important. If you write R here, then O and S and E, rows and ORSE, these were different. But what if if the order is not important? Then for four slots, we have four different arrangements. If we have four vacant places, we have factorial four number of ways to organize it in a definite order. That is NPR. This is this thing. But if we have, let's say, R number of vacant places, and it doesn't matter to us that whether we are taking it in definite order or not, or to say we order is not important. Just taking out the R number of objects from N number of objects is important. Then what will be the number of ways in which this can be taken out? Like we have N number of black balls, and we have to take R number of balls out of it simply. Order is not important. We will select any R number of balls. So this is in definite order, and if we divide it by factorial R, that is the number of ways these R number of balls can be arranged in order, then we have this term NCR, that is combination. That is, combination is an arrangement of taking R number of objects from N number of objects when order is not important. So we will have NCR equal to NPR by factorial R. Therefore, we get the formula for combination, and that is NCR is given by factorial n by factorial r by factorial n minus r. This was for permutation divided by factorial r. Given this is a limit. So combination is an arrangement of n number of objects taken r at a time when order is not important. So this is our formula. Let's have certain observations on this formula. What if first, if r is equal to n, then this is NCn, this will be factorial n. In place of n, r we will write factorial n and n minus r. So n minus n 0. Factorial 0 is 1 and this will be 1. So all taken at once will we have only one way of taking all the balls. So if we have n number of balls, then the number of ways to taking all the balls at once will be one only, like permutation. No order or to be in an order or not in an order is not important. So this is what we mean by this thing. Second is, what if r is equal to 0? This is nc0. This will be factorial n, factorial r, that is 0, and factorial n minus r. So this is n. Again, this is 1. So if r is equal to 0, what is the meaning? That is how in how many way we do not select any ball. If we have n number of balls and we have to take balls r at a time when r is equal to 0, that is we don't have to take any ball. There's only one way, don't take any ball. So this is NC0. Another very interesting observation is when r is equal to n minus r. What will be the value when r is equal to n minus r? We have nc n minus r. This will be factorial n by r. R is n minus r by n minus r, that is n plus r. What we will get? This is factorial n. This is factorial r, and this is factorial n minus r. So again we get NCR. So NC n minus r is equal to NCR. We have another theorem, fourth one, that NCR plus NCR minus 1. This will be equal to n plus 1 CR. You can take factorial n and you can do the maths, you will get this value. So keep it in mind, we'll use it somewhere. We'll see an example on combination. It says the question is, if NC9 is equal to NC8, then find NC17. So we can find NC17 only when we know the value of n. We'll find the value of n from here. So this is factorial n by factorial 9, factorial n minus 9. And this is factorial n, factorial 8, factorial n minus 8. So if we take n minus 8 out of here, then we'll have n minus 9. And if we take 9 out of here, we'll have factorial 8. So this cancel. We take this thing here, this thing there. So this side. So this will be factorial 8 into n minus 8 out of this. Then we have n minus 9. And this side, factorial 9 factorial 8. This is, and this is factorial n minus 9. This cancels. This cancels this. So we have n minus 8 equal to 9. This implies n is equal to 9 plus 8, 17. So n is equal to 17. Then we have to find NC17, that is 17C17, and we know this is equal to 1. Why 1? Because we will have factorial 17 by r, that is factorial 17, by n minus n, that is factorial 0. This will be equal to 1. So this is our first example. So our second example is, we have 2 men and 3 women. Out of these total 5 people, we have to make a committee of 3 people. They can be men and women from these 5 people. So it says in how many ways we can form this committee. Now, the order is not important whether a woman is here, the second woman is here. Here, what you have to see that the order is not important. If we select all the 3 women only, it doesn't matter whether the first woman is at this chair or this chair or this chair. Therefore, this is combination. If order would have been important, then it was permutation. But here order is not important, so this is 3. So out of 5, we have to select 3. The answer will be n. N is 5, C and 3. So 5C3. So what it will be? Factorial 5 by factorial 3, factorial 5 minus 3, 2. So this is 5 into 4, factorial 3, factorial 3 cross 2. This is 2 into 1. So this 5, 4, 2. This is 10. So the answer is 10. So in 10 different ways, this committee can be formed. This is the first part of the question. The second part of the question is, what if we want to have 1 man and 2 women in this committee? Then obviously from these 10 committees only that committee will be there. 1 man, 2 women. So how will we do that? There are 2 men. So sorry, out of 2 we'll select 1 man here, 2C1, and here we have 3 plus 3C2. 2 out of 3. So 2C1 into 3C2. In these number, this is the concept. So we'll solve it and see how many ways this committee can be formed. So 2C1 factorial 2 factorial 1, 2 minus 1, that is 1, into factorial 3 factorial 2, 3 minus 2, that is 1. So this is 1, 1, this is 2, 2, 2 cancel. This is 3 into 2 into 1, that is 6. So there are 6 different ways in which this committee can be formed.